All right, good morning. We're going to run through the way you're going to solve absolute value inequalities today. Okay, so we're just going to separate it into greater than or equal to on the front, and then we'll do less than, or equal to on the back. So let me give you the actual definition, and then I'll show you with a number here. So this is really important. If the absolute value is working with an inequality, this definition only works if k is a positive number. If it's a negative number, we'll have the special case. We'll talk about that at the bottom of the page. So it has to be a positive number. Okay, now this would also apply. This is absolute value of x by itself, greater than or equal to a positive number. This would also work if you had absolute value of x, just a plain greater than some number. They both work. And here's how you split this up. Okay, so I'm going to go with the greater than or equal to. So this breaks into two inequalities. X is greater than or equal to whatever that number, or x is less than or equal to the opposite of that number. So basically what you do is you copy exactly, just drop the absolute value, copy exactly what you have, and then it's an or statement. X is going to be flip the sign and flip the number, kind of like we did with the equations. This is an or statement, and when I remember this as great or, because it's a greater than or equal to. So an or statement, remember when you guys graph these, if I had this on a graph, the two on the number line would point away from each other, one or the other. Okay, so let's just do one with the numbers so we can kind of make a little bit more sense of this. So just think about your absolute value makes everything positive, right? Okay, so the way this would work with absolute value is greater than or equal to 6. So it would say x is any number greater than or equal to 6, or x is less than, so I'm flipping the sign, less than or equal to any number, x is less than any number, less than or equal to any number less than -6. So think about this on a number line here. I'm just going to sketch this, and this is not to scale or anything. So on this end, if I started with 6, right, closed circle, it would include 6. Absolute value of 6 is 6. 7, that's bigger than 6. 8, that's bigger than 6. So all these numbers would be bigger than 6 if we took the absolute value. Okay, this is not spaced appropriately, but the other end I always think is trickier for people, but let me draw a little bit of number line here. So think about this. If you grabbed any of these numbers, like -6, -7, -8, when you would plug it into the absolute value, that would cancel the negative out, which is why you're going to have a situation where all these numbers go into the left. Like if I was at -10, plug it in, absolute value gets rid of the negative, so all these numbers would also make that inequality true. Okay, so here's what we're going to do. These are a little bit more complicated than what I just had above, but basically what you want to do, isolate the absolute value. So I have here, that's already done, 2x minus 5 in the absolute value is greater than 3. So I immediately say, okay, greater. So greater than is an or statement. Just drop the absolute value, just absolutely copy that with no absolute value, or you're going to keep exactly what's in the absolute value, the 2x minus 5, you're going to flip the sign and flip the number. So the number here was 3. It has to be related to a positive number. If it's not, then these definitions don't apply. But flip the sign and flip the number to its opposite. Now, to go through here, what I would do is just solve these like two separate little inequalities, right? I'm going to add 5. So I have 2x is greater than 8. Divide by 2. X, any number bigger than 4, if we'd plug it in, like any number bigger than 4, plug it in for x right up there would make that inequality true. And the other part of it, just literally solve it like two separate inequalities. The algebra, just like we did with the equations, will probably look really similar in terms of the steps, but we'll probably have different numbers over here. So -3 plus 5 would be 2. And then I've got the 2x, so I got to divide by 2. So x is less than, here, 1. Okay, so on the number line, which I know is right above here, I'm just going to try and plot this. So I'm just going to go like 1, 2, 3, 4. And I'll just do like a couple to the side. Okay, so this says less than 1. So open circle at 1, less than goes to the left. So any number less than 1, so like 0, -1, whatever. If we plug that in for x, it'll make it true. Open circle because it's just a plain less than. For this part of it, x is greater than 4, so open circle again here. And any number bigger than 4, greater than goes to the right, so those would point away from each other. And so any number that falls into either one of those categories, if you plug it in for x, it'll make that inequality true. Now, the one next to this, we have to do a little bit of work to get the absolute value alone. So the goal is just to get that set with the vertical bars by itself. Undo any addition or subtraction first. So I'm going to move the 10 first. So we'd have 4 times 1/2 x plus 3 greater than or equal to 64. Now remember, do not ever distribute into an absolute value. It's not legal. So don't distribute. What you actually want to do here is divide. And all that's going to do over here is just cancel the 4 out. And then we have our absolute value 1/2 x plus 3. That's now by itself. Nothing is flipping a sign over. None of the actions I've done. I added 10. I'm going to divide by 4. This is 16. Okay, now this is where you want to get, we have our absolute value alone here. This is where we want to split and use the definition. So I have absolute value greater than or equal to 16. So we're going to split that into 2 inequalities. Drop your absolute value, just copy 1/2 x plus 3 greater than or equal to 16, or copy what's in the absolute value, 1/2 x plus 3. We're going to flip the sign and we're going to flip the number. And again, just solve these like 2 separate little inequalities and we'll put them on the same graph. So here, get rid of any addition or subtraction first. So, whoops, I forgot my x. I'm just subtracting 3, so 1/2 x greater than or equal to 13. Now, to get rid of 1/2, easiest thing I can tell you to do is just multiply both sides by the reciprocal, which would just be 2. To get rid of a 1/2, you just multiply both sides by 2. You could divide by 1/2. That's the same action as multiplying by 2. Either way, whatever your preference is, that's going to not flip a sign or anything like that. 13 times 2 is 26. So x here could be any number greater than or equal to 26. And if you do want to check, I would check it here where you got the absolute value alone. It'll be easier to check and there'll be less steps if you do want to plug in a number and see that that makes that inequality true. Now here on the other inequality we wrote, I'm going to subtract 3. I'm just subtracting 3. It doesn't flip a sign or anything. Negative 16 minus 3 is negative 19. And the same action I did on that last question. To get rid of the 1/2, I'm just going to multiply both sides by 2. Or you could divide by 1/2. It'll give you the same answer. That does not flip a sign or anything like that. So negative 19 times 2 is negative 38. This is an or statement. They should point away from each other. So just go up to the lovely little number line up here. And I'm going to, these are not spaced out right. So I'm going to put negative 38 somewhere on the left, positive 26 somewhere on the right. Both of these would be filled in circles. Anything bigger than 26, so like 27, 28, if you wanted to give a couple examples, or anything smaller than negative 38, like negative 39, negative 40, would solve that lovely inequality. Okay, now the last one is a special case. So really, I have an absolute value by itself, and maybe I'll just write it like this. Absolute value by itself greater than or equal to, this is now a negative number. In this little example, it's negative 30. Okay, so I want you to think about this, because if it's related to a negative number, you can't apply the definition. But absolute value, I would ask you in class if we were here, like absolute value makes everything what? And you would tell me absolute value is the distance from a number to 0 on the number line. So no matter what, on the left side of it, doesn't matter what this is, I'm always going to have a positive number. Okay, now I put this on here on purpose because sometimes it trips people up. So the way I have this related is greater than or equal to. A positive number is never going to be equal to a negative number, but that's the key to this. This is greater than or equal to. And in that situation, a positive number will always fall into the category of greater than. It's not going to be equal to, but it will always satisfy this. Whatever number is here, it will always be bigger than a negative number. So if you have an absolute value greater than or equal to, or a plain greater than, this would work if you just had absolute value greater than some negative number. The actual answer here is all real numbers, because a positive number is always greater than a negative number. It doesn't have to be equal to. In terms of the number line, it would literally just be like a line on top of it. So as you're going through these questions, if you get an absolute value related to a negative, it's going to be a special case if it's greater than or equal to all real numbers. Okay, now on the back we're just going to switch to less than. So this is super similar, and again, it has to be, your absolute value has to be related to a positive number or this doesn't apply. So if you're less than, I remember this as less than. These are going to be and statements. These are going to point towards each other. So you're going to drop your absolute value. X is less than or equal to, in this case, K. And these are going to point together. Same kind of a concept. You're going to drop the absolute value, flip the sign, and do the opposite of that number. There is another way to write this. You can put X in between the number and its opposite. And if you want to do it that way, you can. It might be easier to remember the definition to just drop it and flip the sign, flip the number. So I'll show you both. So X is less than or equal to 4 here. All right, so this would mean X is less than or equal to 4, and meaning I have to satisfy both of these inequalities. X is greater than or equal to negative 4. You could also write this with the X in the middle. Notice I'm not changing the direction of the inequality symbols or anything like that. The little part here points toward the negative 4. That's the case here. I'm just kind of putting X in the middle to write this as a compound inequality. Let me have you guys think about this for a second. All right, so like negative 4, negative 3, negative 2, negative 1, 0. I'm going to try and fit this. Whoops, 1, 2, 3, 4. Okay, now in this scenario, if I'm less than 4, right? Any of these numbers, 3, 2, 1, 0, negative 1, cancels out the negative, negative 2, negative 4. Plug that in, that'll make that inequality true. Once I get outside that, like here, negative 5, if I put in negative 5, that negative gets canceled by the absolute value, and now negative 5 in absolute value would be greater than 4. Same thing like on the other end, like if I did 5, 6, whatever. 6 is bigger than 4, so now I don't work with my absolute value inequality. So these should point together. These will be an and statement. So just like the ones we did on the other side, the first goal should be to isolate the absolute value. So get rid of any addition or subtraction first. So on this guy, I'm going to subtract 3. So I'd have 5 times absolute value x minus 6 is less than 75. I'm going to divide by 5. Absolute value of x minus 6 is less than, this is going to give me 15. Okay, now, once you got your absolute value alone, you're going to break it apart into that little definition. And so I'm going to write x minus 6 is less than 15. The only difference here is and these should point together. X minus 6 is greater than negative 15. We're going to be between these two numbers. I'm just going to add 6 real quick. X is less than 21, and here I'm going to add 6. X is greater than, this will be negative 9 if I take negative 15 plus 6. Now, you have to work for both. All right, so if you think about a number line, you got negative 9 would be on the left, 21 would be somewhere on the right. You're bigger than negative 9, so it would be an open circle going with an arrow that way. Less than 21 would be an open circle going this way, and they would point together. If you prefer, what you can do right here, let me come down here, You can do negative 15 less than, put what's in the absolute value in the middle, and then that positive number on the end there. You could solve this just in one inequality. I'm going to add 6 to all three parts, and this would give you exactly the same inequality as what I had there, so it's really a preference, whichever one you like better. This just says x is between those two numbers. Okay, and then let's do one more real quick. Get your absolute value alone first. So 2x plus 3 in my absolute value less than or equal to 225 if I add 7 there. Excuse me. Okay, now 2 ways to do this. Just drop your absolute value, 2x plus 3 less or equal to 225. And 2x plus 3 is greater than or equal to negative, so I'm going to flip the sign and flip the number. The other way you could do this, let me do it on this one. I'm going to put the 2x plus 3 in the middle. And you could just, if you wanted to go back to the original, just go ahead and copy that inequality, and what you would do is on the other side here, just add this negative 225 and make the 2x plus 3 greater than that. This would be in the middle. Both arrows point into the left here. This is saying what's in the middle is bigger than this but less than this, and you can solve it all at once if you would like to. So this would be negative 228 less than or equal to 2x less than or equal to 222, and divide by 2. This is negative 114 less than or equal to x less than or equal to positive 111. So that just means, and you don't have to draw these to scale or anything, I'm just looking for those two numbers. X could be any number between negative 114 and 111. Okay, very bottom of the page. This is a special case again because I have an absolute value here and it is less than or equal to, in this case, negative 11, but really just want you to think about in general. You have an absolute value by itself related to a negative number. It's going to be a special case. So absolute value, like we said on the front, makes every single thing positive. And this is saying we have a positive number less than or equal to a negative number. Okay, now, the or equal to is never going to happen, so don't worry about that. What you need to ask yourself, is a positive number less than a negative number? A positive number is always bigger than a negative number, so this is never true. Never true in this situation. So if you have absolute value by itself less than or equal to a negative number, that's never true. So that situation would be no solution. You only have to worry about that if your absolute value by itself is related to a negative number.